All right, this is the sheet, polygons. All right, and you can see here, I list the number of sides and the name. It's a triangle. If there's 3 sides, it's a triangle. Number of degrees, I said this in the intro, 180. We're only going to worry about 2 of those, quadrilateral and a triangle, and we won't worry about the rest. All right, and you can see here I have the definition, a closed, and that means there's no gaps, plane shape made of 3 or more sides. The sides are all line segments, and that's important because that means that there's no curves involved. All right, you can't have a curve. A circle is not a polygon. It's not. It's closed, but it doesn't have line segments in it. All right. Oh, and here I have this too. A regular polygon. A regular polygon, all sides and angles are the same. All right. Now here's triangles. The first one we deal with is an acute triangle. And an acute triangle, all angles are acute. That means all 3. By the way, there's always, as I keep saying, by the way, I noticed that. I say by the way a lot, and I say piece of cake a lot. Why is that, Tulip? You don't know? I don't eat cake. All right. Now, a jack-o'-lantern eye, your typical jack-o'-lantern eye, is an acute triangle. All 3 of these angles are less than 90 degrees. And we'll label them A, B, C. And by the way, the symbol, oh, I said it, see? The symbol for triangle is that, regardless of what the triangle looks like. Triangle ABC is an acute triangle. Now, notice, acute is a type of angle. So these triangles are named for their angles. A right triangle. A right triangle has one right angle. It's a triangle with one right angle. Okay, and I can indicate that. That's not closed, man. Close up. All right, that's a right triangle. Now, why can it only have one? Because the sum total of all the angles are 180. You can only have one. Okay? That's a right triangle. Okay? An obtuse triangle, there's one obtuse angle. Why? Because again, it can't exceed that. So look, this is how I do it. That's an obtuse angle. And then what? I just connect those 2 sides. That's what an obtuse triangle looks like. All right, now, the next series, the next 3 names, the book doesn't use, but I'll go over, and they deal with the interaction or the relationship of the sides or legs. They could be called legs of a triangle. Equilateral, that means equal lateral sides, equilateral triangle. And that's almost like the first one that we drew, like that, all right? That's an equilateral. If I measured it, it's about the same. By the way, that's also a regular polygon, all right? It's a regular triangle because if all 3 angles are the same, what are they? 60 degrees, 60, 120, 180, okay? Isosceles triangle, exactly 2 sides. I can't say 2 sides because 2 sides are equal here. Exactly 2 sides. All right? So how would be the best way? If I would make it like this, and I drew that same length, those are the same, and then I connected it. Oh boy. Well, that's kind of different. But you can see this side is much longer than these 2. All right? By the way, you could, oh boy. You could have a right triangle. That's, I said, by the way, a right, it has nothing to do with the angles here. It has everything to do. Isosceles. ISO means the same, right? ISO. ISO bars on a map. That's when you connect on a weather map. That's when all the barometric pressure is lined up and you get a weather map that way. Also on a geographical map, a topographical map, same elevations are connected together, and that makes an isobar. All right, scalene. No sides are congruent. So here, I'll go like that. I'll go like that. And then like that. Hey, that looks like it could be, it might be an acute triangle too. It is so hard to write. Did anyone experiment and see what I'm talking about, trying to write through your phone? All right, that is not the right angle thing. All right, no sides are congruent. All right, oh, and that's it. Next tomorrow, quadrilaterals. All right, it was wonderful seeing everyone today. I'll post this up and try to do the number 2, 10-2. All right.